Hello all, my name is Sivanjan Chaudhary and welcome to my YouTube channel. In this particular video, we are going to continue with set theory. Okay, so if you haven't watched my previous videos yet, I would ask you to please go and watch those videos and you'll be able to understand this particular video in a much better way. Okay, so in this particular video, we are going to understand what is the difference between set union and set addition. Then we are going to understand the various properties of set operations. And thirdly, we are going to understand about what are power sets and what is the cardinality of a power set. So, so our first topic is set addition versus set union. Okay. So in my last video, I had discussed about what is set union. So if I take two sets, say one is A, 1, 2 and 3. And the second set is B, which is nothing but 3 and 4. If I want to unite these two sets, okay, so A union B is going to give me nothing but 1, 2, 3 and this 4, right? So 1, 2, 3 and 4. So this is nothing but set union, right? So if it is A and if this is B, set union is nothing but the entire union of these two sets. Now, if I want to add these two sets, right, what will be the result? So if I write A plus B, it will be 1 plus 3, then 1 plus 4, then 2 plus 3, 2 plus 4, then 3 plus 3, and then 3 plus 4, right? So what will be the output? Say 1 plus 3 is 4, 4 plus 1 is 5, 3 plus 2 is 5, 4 plus 2 6, 3 plus 3 6, 4 plus 3 7. Now what we are going to do is we have to eliminate the the identical, I mean the two common elements, right, 5 and 6. So it will be 4, 5, 6 and 7, because a set consists of only unique elements, no duplicacy is allowed. So this 5 and 6 are duplicated, so we basically remove it. So this is the difference between set addition and set union. So in case of union, we try to unite the two sets. Okay. In case of addition, what we are going to do is we are going to basically add the two sets, add each element to every other element of the other set. So I hope you are able to understand set addition and set. What is the difference between set addition and set union? So now we are going to understand about the second topic, that is nothing but properties of set operations. Okay. So what are the properties of set operations? They are, okay, so number one is called as associativity. Okay, associativity of set. So what do you mean by associativity of set? What it says? It says that, say we have got three sets, okay, A, B and C. A, B and C are nothing but three sets. So what it says is, it says that A union then B union C is nothing but equals to A union B then whole union C. Okay, so first what we do is B union C we unite, and then we unite the resultant set with A. What result we get is going to be equal to first uniting A and B, and then the result of these union when united with C, whatever result we are going to get, these two sets are not going to be or basically these two sets are going to be same. Okay, the second thing is related to intersection. Okay, so the same thing, that is A intersection B intersection C is nothing but equals to A intersection B then whole intersection C. Okay, so let us try to prove this associativity law with the help of an example. Okay, suppose we take A as 1 2, okay, B as say 2 3 and C as say 3 and 4. Now first law says that A union whole B union C is nothing but equals to A union B then whole union C. right? So let's first unite B and C, okay? So B union C, what is B union C? So 2, 3 and 4 we are going to get, right? So B union C is nothing but 2, 3 and 4. Now if I unite this, the resultant set with A, right? A. So 1 and 2 is there and we have got 2, 3, 4. What will be the resultant answer? So A union B union C is nothing but we are going to get 1, 2, 3 and 4, right? So 1, 2, 3 and 4, right? Now if I do this thing, so first unite A and B, so what we are going to get? So this is the left hand side, okay? This is the left hand side. In case of right hand side, what we are going to get? So if I do A union B, so A union B is obviously 1, 2 and 2 and 3. So 1, 2, 3 will be the answer, right? 1, 2, 3. And finally, we are going to unite it with C. So 3 and 4. So 1, 2, 3 and this 3 and 4 when united will give you 1, 2, 3 and 4, right? So the answer will be 1, 2, 3 and 4. Right? So you can see that both the left hand side and right hand side are nothing but equal. Okay, so both the sets are nothing but equal sets. So this proves that this associativity law holds true. Now in case of union, I have shown you the example. In case of this intersection, please do it by yourself and you can say whether you have got the answer as correct or not, if you are able to prove the associativity law or not. Okay, so next comes commutative law. Okay, it says that A union B must be equals to B union A and A intersection B must be equals to B intersection A. Okay, so let us prove this with the help of an example. So I'll prove the first one, you prove the second one. Okay, so let's take A as same 1 and 2 and B as 2 and 3. What is A union B? Obviously 1, 2 and 3. What is B union A? Obviously 2, 3 and 1, 2. Obviously 1, 2 and 3. So this also is proved. So the third property is identity property of union. Okay, identity of union. So what I'm going to do is, it says that A union phi is nothing but equals to A. So what is phi? Phi is nothing but empty set. Okay, so it basically denotes empty set. So when you are uniting a set with an empty set, obviously what you are going to get as a result? Obviously that particular set itself, right? So because empty set is nothing but empty, it has nothing, so it's going to get included, right? So empty set is going to get included, and what is the result we are going to get? We are going to get A. For example, I write A and 1 and 2, and we have a phi as an empty set. Okay, so phi is empty set. So if I am uniting A union phi, what I'm going to get is 1 and 2. Okay, so the next topic is intersection of empty set. The next law is intersection of empty set. It says that A intersection phi is nothing but phi. Obviously, right? Because if I have a set A, okay, and if I have a set which has got nothing in it, so obviously there will be nothing common inside between these two sets, right? So when I am going to intersect it, obviously I am going to get an empty set, right? Therefore, say A is 1 and 2, right? And we have an empty set phi. Obviously, there is nothing common between 1 and 2 and phi. So what will be the output, or what will be the answer? A intersection phi is nothing but an empty set, right? The final property is distributive property. Okay, distributive. It says that A union B intersection C is nothing but equals to A union B intersection A union C. And the second one, it says that A intersection B union C is nothing but A intersection B union A intersection C. So let me prove the first one. Suppose we have got A which has 1 2, B which has got 2 3, and C which has got 3 4. Now if I first prove the left hand side, what is B intersection C? B intersection C is nothing but 3 and 3 common, so it will be 3, right? And what is A union B intersection C? A union B intersection C will be this 1 2 and this 3, right? Now proving the right hand side, what is your A union B? What is A union B? What is A? 1 and 2. And what is B? 2 and 3. What is A union B? 1 2 and 3, right? 1 2 and 3. What is A union C? A union C is A union C is this 1 2 and 3 4. So it will be 1 2 3 and 4. 1 2 3 and 4. Now what I need to do is I need to take the intersection of both these sets, right? A union B and A union C. So what is the intersection? What is the common element? 1 2 3 and 1 2 3 4, right? The common elements are 1 2 3, right? 1 2 3. So what will be the answer? So basically it will be 1 2 and 3. Therefore this and this sets are nothing but equal sets, right? So this law is proved, right? This law holds true. Similarly, you can try with the second one. Okay. So our last topic for this video is power set. So what is a power set? Suppose I give you a set, okay, 1 2 and 3, and I ask you to find the power set of this particular set A. So you'll write PA, and you have to include all the combinations of elements uh, in this particular set along with the empty set, that is 5. So you have to write 5 1, and everything has to be in a set format, okay? So if you write 5, it has to be inside a set, okay? 1, it has to be inside a set, then 2, then 3, okay, then we have 1 2, it's also a combination, okay, then we have to write 1 3, then you have to write 2 3, and finally 1 2 3. So this is nothing but the power set of this particular set A. So what is a power set? A power set of a particular set is nothing but all possible combinations of all the subsets, is a subset of all possible combinations of the particular elements inside this particular set, including the empty set. Okay. So you have to include all the elements inside a set, combination of all the elements inside set. Each set will hold all the combination of elements, and you have to make it in the form of a set finally. So this is nothing but power set. Now if I want to ask you, or if I ask you, what is the cardinality of this particular power set, say P of A, what is the cardinality of P of A? You can easily say 1 2 3 4 5 6 7 8. 8 is nothing but the cardinality, or the number of elements inside this particular set, right? Now what is the generalized formula? So 8 can be written as 2 to the power 3, right? Okay, 2 to the power 3 is nothing but 8. So what is 3 here? 3 is nothing but the number of elements over here, okay, and 2 is nothing but the base. So the generalized formula of a power set, okay, is nothing but 2 to the power n, where n is nothing but the cardinality of S, right? That is the cardinality of a particular set. Let me give you one more example, okay. So if I ask you, try to find out the cardinality, of this particular power set, of the power set of this particular set, okay. So if I ask you to find out P of A and its cardinality, what will be the answer? It will be 2 to the power 1 2 3 4 and 5, okay, 2 to the power 5. whatever value you get, you put it as the answer. You can check it also by expanding the this particular set, and this you will get the answer. Okay. So with this, we are done with this particular topic of power sets. So I hope you are able to understand power sets and all the topics which we have discussed before in this video, right? Including the, the properties of set operations, and also the differences between set unions and set addition. Okay, so what I'm going to do is, obviously I'm going to write all this stuff down, put it in my Google Drive, the link of which you are going to get in the description section below. If you have liked my video, if you do like my contents, please do like, share, and subscribe to my channel. It will be a very good moral boost up for me. Okay, and I'll be coming up with more such videos in the future. Till then, stay safe, have a great day, and bye.